Okay, I think we're ready. And make sure that this looks right. I think that looks right. Okay. Last time we did a nozzle change. Is what we did last time. So we had the printer, and we changed out the nozzle. Now I thought it had a 0.6 millimeter in there, and I wanted to go down to a 0.4. It was a 0.4, but we went through the process. Let's see a question. Will there be due dates for this time? Oh, okay, so the assignment due dates, there are in the syllabus, there are due dates as far as, hey, they're more like pacers, just keep on this schedule to finish the thing without having, finish the course without having to do everything at the end. But technically you can turn everything in at the end or near the end of the quarter, which is August, second week of August sometime. So the due dates are more like suggestions of when you should do them versus like hard dates that if you're after that you're late. So there are somewhere in between. The actual due date is the end of the quarter or the last week of the quarter anyway, but there are some recommended ones in the syllabus. Also for the calibration, can they be any? Oh yeah, so I put, we haven't really talked about those, but actually we're going to talk about some of them today. The calibration prints that I have set up are, I have a temperature tower, a tolerance test, and a retraction test. And I put 3 specific ones on canvas so that you could just use those. You can use any 3 that you want though, and different ones. Maybe you want to do a flow rate test or something like that. That's fine, and you get your own model. But there are 3, so you have to do 3 calibrations. You don't have to do the exact 3 that I put out. Those are just 3 good ones to do. The one thing with the temperature tower is that I have a pre-sliced one, so that if you don't want to go in and change the temperature at every layer or every 10 layers or whatever it is, then there's one it's the actual raw G code where you don't have to go and slice it. If we feel the images of our benchy did not, would it be okay to? Yes. So if you're actually in town somehow, where you can bring the benchy to me, that is totally fine. Now I may not be in my office all the time, but you can leave it in the mailbox in one of the offices, the admin offices. So yes, you can totally bring it. Now you retracted your question, but I did see it. All right. Let's see. Last time we did the nozzle change, we talked about PETG a little. Oh, we talked about PETG because I wanted to print the wings. I'll show you those in PETG. I think I've actually printed them now, so we'll look at those. But I printed them in PLA. If you're not, so probably the best place would be the mechanical engineering office. I have a little mailbox in there, so you can put it in there. It's a little cubby hole type of thing, but it has my name on it, and it'll fit benchies at least. So that would be the best place. Let's look at what I printed. So, whoops, that was loud. Let's go to here. So I have let's zoom out some. There we go. I've also, the canards, or I think that's how, canards, yeah. I think that's what those are called. Little winglet things at the front. I didn't have any of those to go off of, but it was the same process, more or less, as the wings here. I'll show you what I did here. So here it is. I just found an overhead view on the internet somewhere. So someone had taken pretty good overhead view that did have those little canards on it. And I just used that same process that I used for the wings, so I didn't really think that would be interesting to see again because it's almost exactly the same. The only difference is these have these little tabs that I didn't have any reference for, so I ended up just measuring the slots that they go in. So they go in these little slots, so I just measured those with calipers, which are around here somewhere, and I did have to print them a couple of times, a couple of wrong sized tabs in there. Those weren't, so this is a point. I did print the entire thing here, but if you get into a situation where you've got a piece that interfaces with something else, and it's a long print. These were not terribly long prints, but if you do have something, just print the one little piece that has to interface. You know, print 10 layers of that piece, or isolate it somehow so that you're not printing the whole thing over and over again. You can isolate it just in the slicer. You don't have to go model it separately. You can just, let's say that I wanted to print just these little interface pieces. Let's open up Cura and I'll show you what I would do. Apparently I have 2 Curas open. So here's what I would do if I wanted to just print that little piece. I would go to find, hopefully I can find it somewhere, probably on the desktop. That. So here it is. First of all, it comes in a weird position. It comes in based on how you oriented it when you made it in your CAD program. So I would like to print it with this surface facing down. So what you would do is you would go in here and rotate, and there's this option here. There's this option that lay flat. Sometimes that'll get you what you want, but it's not going to necessarily pick the exact surface you want. This one, you click on this and you can pick any face. So I could just pick this face and it'll lay it down flat. So now this orientation would print the whole thing. But if I only wanted to print that little tab sticking up, then I need one thing I can do. There's several ways. The easiest thing is just move the part and drop it down below the print bed. And now sometimes when you do this, it'll snap right back up to the print bed. So there are options to make sure that it doesn't do that. If your slicer just keeps popping it up to the print bed. I don't remember exactly where it is, but I think it's actually this one. Drop down model, although it's checked, so I'm not sure. Maybe there's an option that makes it where it always lands on the bed, even when you put it below the bed. And you might have to find that for your particular slicer and turn it off. But here, now when I slice it, most of the part is below the bed, so it won't slice that, and it'll just slice the piece that you want. Now this one is really small, so you might want to put a brim on that piece, but you go down to a 4-minute print from this one wasn't terribly long, but a 25 or something minute print. I did turn ironing on some of these. I'll see if I can find one with that and show it to you. So that's a way to test just the piece that has to interface. So you just print that over and over again versus printing the whole part over and over again. Let's see if I can find the one that has ironing on. Alright, so I did not tune ironing, but I did turn it on. I don't know if it's going to show up very well. Here's where we're at with our X30 Conquest. Alright, let's see if we can see the difference here. So, don't know. Maybe with a light. Oh, that helps a little bit. Now it over-exaggerates it. But you can, in this one, you can definitely see the lines, right? Those are the top surface lines for just regular print. This one has been ironed, and you can see how it's really hard to find. You know, if I get it just right, there's some of the layer lines. You can kind of, well, not layer lines, but the surface lines. But it really does do a pretty good job of hiding the lines, where this one, you know, they're much more obvious. Now it's actually pretty good even with the ironing turned off. But ironing, what it does is it will basically drag the nozzle across the top, any flat surfaces that are at the top of the model, and extrude a tiny bit of filament to try and flatten it all out. And so there are settings that you can do to tune that to make it a better surface. But if you want a smoother, flat surface, it does have to be flat. It doesn't do non-planar ironing. There is a way to do that, but it's not in most slicers. So it does have to be a flat surface, which this is, and a top surface. And it can either be the topmost surface or any top surface that's flat. I think I did any top surface, otherwise it would just iron that little piece up there. So it does make a difference, and you can tune it to make an even better difference. Technically, if you have a heat gun, not a heat gun, a soldering iron, with a broad flat tip. They make some special broad flat tips for this kind of thing, not necessarily for ironing plastic, but for ironing various things. You can iron it afterwards with something like that. So there are ways that you can post-process your parts to make them less 3D printed looking. All right. Let's see. That takes care of that. Oh, I wanted to show you a filament. I found a sample of one filament here. Let's zoom back out. Where are we at? This is a dual silk. So it looks blue, but on that side it's green. And so what this is I don't know if you'll be able to see or not, but the filament is two-sided. So let's see if I'll try and zoom in. I don't think you can start to pick it. Yeah, you can definitely see it in there, where one side of it is one color, the other side is another color, and they have tricolor and all this kind of stuff too. This filament is pretty interesting. It's more a novelty than any functional thing, but it gives you a way to add color to your models, where if you don't have a multicolor printer or you don't want to change the filament out, it's a way to add some interesting color effects to your model. So this would be a dual color filament. And like I said, they make tricolor. I don't know if they make quad color. Probably somebody does, but they make some filaments that are from different directions, different materials, or different colors. Not different materials, different colors. But it prints just like normal. It's just PLA. Now I will say, this is a silk. Any of the silk filaments, doesn't matter if they're dual color or not, but silk filaments are they are more brittle, so they don't have as good, and not brittle is not the right word, they don't have as good interlayer adhesion. So the monomer or whatever it is that they add to make it silky, so this is a very shiny, like it is very shiny when it's printed. And so it looks really cool, but they're not very good for structural or stuff that has to carry much load, because they delaminate pretty easily. So not like they're going to fall apart in your hands, delaminate, but if they have a load on them, some kind of strain, then they will probably fail way before the same thing but just plain PLA would do. So if you are using a silk filament, then use it for decorative things. That's totally fine. Just be careful with using it for anything that is structural. The ironing settings are in, at least if you're using Cura, and others are similar, but if you're using Cura, the easiest thing is it has this search bar right here, and just start typing what you think the thing is. So iron, and it will come on. It will isolate that option in your settings. So enable ironing is technically, for Cura anyway, the name for it. I think all the slicers call ironing the same thing. They all call it ironing. So you can search for iron or ironing. There are some settings between slicers that are not the same name, but they do the same thing. But ironing is one that in all the slicers, I think it's always called ironing. And so you enable it, and then you can start. I did not change any of these settings for the one that I use, but you can change them a little bit to tune it to your material and your printer. So I'm going to turn it off for right now. I don't normally keep that on. It does take extra time depending on how big of a surface area it has to iron. All right, let's see. We talked about our silk. We looked at the X30. So back to the X30. We're not going to model anything today, I don't think. Maybe we'll start something. I don't know. But we have gotten some pieces. I am going to print them in black. I'm just keeping them. I just had green filament loaded, so that's what I used. We've got a couple of options for what's next. I think the next thing we're going to do is, I have one of the missiles. So it's supposed to be 4. 2 on this side and 2 on the other side. I have one. This one looks like a relatively easy model to create in a different program. So just for variety of, hey, here's how you do different CAD modeling. Well, I don't know if I'd call this one CAD modeling, but I guess technically it kind of is, but it is 3D modeling. We'll call it that. This one is probably a decent example for that piece of software. So we'll do that. Maybe we can do that Wednesday, or at least start on it Wednesday, and we'll try and model these guys up. It is yellow, which I'm not a fan of printing yellow because, as I told you earlier, it kind of smells bad to me whenever I print yellow. But maybe we'll print them in green like all the other stuff. We do have to figure out how we're going to print this, though, because I guess we could print it standing up or in two pieces somehow. There's not an obvious bottom or top that would print flat, so that is something we'll have to consider on when we model this, is how are we going to actually get this printed. Maybe this would be a decent one for some resin printing, so we haven't done that. Maybe that's what we should do. All right, today's stuff. Let's see. Today I was going to talk through, I'm going to close Fusion. Yes, I'm going to close that. Got to save the file so that I can close Fusion and get some resources back. What is this? I have several files open. All right. Today what we're doing is we're going to talk about retraction and flow. So these are two settings that you can modify mostly on the slicer side of things. So these two do different things, but they are kind of related. We've sort of talked about flow when we did E-steps. So I would not worry with either of these settings until you're sure that your E-steps are pretty right. Now, if you've not done anything to your printer to change, remember E-steps are the stepper motor that's feeding the filament into the hot end. It needs to be calibrated to feed the right amount of filament, the right length of filament. And if you've not changed anything on your printer, it's straight from the box, then you shouldn't have to tune E-steps. But if, like this one, you have changed, where's it at? Crooked. You've changed the feeding mechanism, like this one I did, then I do need to tune that. So we've already been through that process. You could go back a couple of videos, I think, and look at talking through the tuning. I don't think we did. We ran some filament through there. I think we did on the stream. I don't remember now. So I wouldn't worry with retraction and flow calibrations until that is good. So either you haven't changed anything or you have set up your E-steps. So what these two things do are retraction has to do with, and I wrote a little bit here of what retraction is and some basic settings. So the idea for retraction is that there's pressure built up in the path where your filament is being fed into the hot end. So for ours, we just have this little short path right here, but for a printer that have the Bowden tube that might be, I don't know, it might be 20 inches long or something, there's a lot of pressure that could be built up when the feeding mechanisms tries to feed filament into the hot end, and then you stop feeding all of a sudden, like you're done with the layer or whatever it is. Then that pressure that's in the tube will continue to extrude filament even if your feeder, the stepper motor, is not pushing filament out. So if you can tune that to where it either in this case retracts filament, so it's going to pull the filament back out of the nozzle so that it won't ooze everywhere. So if you're getting really bad stringing, so you print your parts but there's little strings of filament all on it that you didn't plan to print, one obvious thing to check is your retraction settings. So I've got a couple of generic settings here. So retraction distance and retraction speed are the two prominent settings, and distance is kind of the most prominent setting that affect this. There's a bunch of little settings, but distance is the most direct factor, and then speed, how fast are you retracting, is the other factor that are controlling most of your retraction. So there are two sets here. There's the Bowden tube, so like the Ender 3 would normally be, although this one has the direct drive on it. So direct drive, again, is your stepper that's feeding the filament is really close to the hot end. So I've got, you know, a very short filament path there. I would call that one direct drive. But when you've got the feeder mechanism way over here and there's a tube running over to the hot end, that's a Bowden tube. And the settings for retraction distance for a Bowden tube, 4 to 6. I mean, you can go outside of these ranges, but these are typical starting point ranges, which your slicer should already have in there. You just may want to fine tune it. In general, the shorter the distance, the better it's going to be, because it's going to have to retract less filament. So you want to see what's the minimum that I can get away with and still not have strings everywhere. Direct drive might not even be a whole millimeter. Like I've got half a millimeter here, up to 2 millimeters. And then the speeds you want as slow as possible, because the faster you have to retract filament, the faster your stepper motor has to run, and that could cause wear, unnecessary wear on your stepper motor that's feeding the filament. It could create maybe it can't go that fast. So there's some reasons why you want to be as slow as possible. So you want as little as possible retraction and as slow as possible retraction. But too little, too low, you'll get a stringy print. So the tuning procedure is you're going to print a stringing test. So there's several of these. I think in here, did I link? Yes. So this page right here is going to send you, and if you can't click, obviously you can't click on it while you're in a YouTube video, but if you search for this, it should take you to here. And what this is this is a YouTuber. He's in Australia. He's been around a long time, but he takes a very measured, logical type approach to his videos. So they're all really pretty good. But what he's done here is he has written several scripts that will generate files that you can print to tune your printer. And if you want to do all of them, then I'll have to get my picture off of it. You go through in order, and they're more or less set up in the correct order of what you would do. Like, first of all, just make sure the printer's not wobbly, do a frame check, then make sure all the bolts are tightened and the frame is square, that sort of thing. We talked about the PID tuning earlier on, where you tune the actual coefficients that go with the tuning algorithm for your hot end and your bed. So he's got a tab on how to do that a variety of different ways. There's the E-steps. So we've already done that. He's got a section on how to do E-step tuning. First layer, we did first layer. Remember, we printed the 9. I don't know which one he does. It looks like he prints maybe he does 5. So you can kind of see him in there. He prints 5. We did 9. Same idea though. And now baseline print. So here he's saying print a calibration cube. I did that early on. What he's doing with this one is you don't use it so much for calibrating anything, but you use it for, are these follow-on calibrations making any difference or not, with a real part, not just the calibration part. All right, so then he actually has slicer flow calibration next, and he's got retraction over here. We're going to go ahead and do retraction first, although I guess you could make an argument that you want the flow rate correct first before you do retraction. It'll be okay. And let's see if we can zoom in. So in this picture, all of this little, now these are kind of small wispy things, and you may be okay with these, but this is poorly tuned retraction, although there can be way worse. If it's looking like this and you can't really tune it any better, these are actually pretty easy to remove with just a hairdryer. You can take a hairdryer or even a lighter or any kind of heat source and these will almost totally disappear if you just brush over it with a heat source. So those are more, you could probably tune it better to not get those, but I'm actually thinking of way worse retraction. All right, so how his site works, and we'll use his site for this, is you pick which of these slicers are you using. So there are a limited number. He hasn't updated this in a while, so there's none of the Orca slicer, bamboo slicer are not in here, but Cura is. So we're going to say we're going to use Cura. And then he tells you, well, in Cura, these are the names of the main settings. So we already talked about distance and speed. We know what those do. And then extra restart distance. So this one I normally don't do anything with, but what it's doing is once you've retracted the filament and you want to print the next layer or the next piece or whatever it is, then you've got to put the filament back to the nozzle. And sometimes that will lead to little gaps. And so what this extra restart does is it will give you a little bit extra filament so that you don't have a gap there. Oh, all right. So you replaced your entire hot end and your secondary. So secondary meaning the part cooling fan or the one that's facing the heat sink. The part cooling fan, it's controlled in the slicer, so you can tell it to not be on. Maybe you printed some ABS or some material that turned it off and it's just not going to be on. But if it's the one that's cooling the heat sink, that one should be on all the time. So things that can happen when you're replacing stuff is it is possible to actually damage the fans or the wiring. Those wires are pretty small for the fans. So it's what I would check is, little aside, I would go to, assuming you have a menu like this, you can actually turn the fan, the part cooling fan, on and off in here. And I don't remember the exact, I think it's in the temperature maybe or something like that. There is a way to turn the fan on here. And that side fan, so this is the part cooling fan on the Ender 3 and it's shooting air down this way. You can, if it doesn't come on, then it might be that a wire has come unplugged. If this fan, the one that's on the hot end, that one should be on all the time pretty much. It's actually, even like mine is on right now and the printer's not doing anything. It was the fan on the side. So the fan on the side, this one, it can be off, and it will be off. Typically slicers have this one off on the first layer no matter what print you're doing. So I would go to the menu here and try to turn it on manually and make sure it still can function, because it could just be that you only looked at the first layer, because it does not, this one is normally not on until the second layer, and then only if you're printing PLA. Or in PETG, it might be on, might not be on. It's kind of slowish. So maybe check and make sure that it's coming on through the menu here, or just print something that has, and wait till the second layer. And it shouldn't be on at all until the second layer. What you're doing with this one on the part cooling is normally you want the first layer of any material to print really hot so that it sticks to the bed really well. And so that usually means you don't cool it. And then the second layer, this should ramp up and start cooling, assuming you're printing PLA. So check on that and see if that's what's going on with it. Let's see what else. Oh yeah, extra restart. So that's just a little bit of extra filament. It retracted 5 millimeters and it unretracted 5.5 or whatever extra you added. The unretract speed, same thing, except how fast are you getting filament back to the nozzle. Z-hop is a little bit different. So Z-hop, we might have to draw some pictures for that. Let's see if I can find something that'll draw here. All right. So let's say that nozzle's over here and you're printing something that has some little towers So this is your print. All these layers. So what Z-Hop does is when you're over here printing, let's see, there we go. You're over here printing back and forth. When you go to move over here to print, it's possible that you would drag filament from one post to the other. And so what Z-Hop does is it says, all right, you're finished with this layer, bump up a little bit and go across so you're not dragging filament from one post to the other. So Z-Hop will help with making sure that your nozzle doesn't drag fresh filament from one side to the other. So you can actually raise the nozzle up, move, do your travel, drop it back down, and print on the other side. So that's what Z-Hop does. So, and it's usually like a millimeter or something. It's usually a small amount. All right, so let's set up this test. It says we do have a 0.4 millimeter nozzle. 0.2 millimeter layer height sounds good. Oh, I didn't think about this. This printer is not running a normal operating system. I've talked about Clipper. This printer is running Clipper. So we might have some issues. I think Clipper will just ignore them though. So we'll see. We'll see what happens. ABL is automatic bed leveling. This one does have an ABL. I don't want to create a whole new mesh though. We'll just say that it doesn't have it. How big is the bed? This is actually a 225 by 225. This is so it will center. We'll do that. I normally print at 205 for the material that's in there right now. It's just a green PLA. Bed temperature, I usually do 50. It is PLA, so this is that fan we were talking about, the part cooling fan. I want it at 100%, and then starting on, see, look, they've got it set to layer 2. You can go several more layers. We'll just say that it doesn't come on until layer 2 though. And here's what's going to get printed. It's going to print one section called layer A, where I can change any of these settings that I want for layer A, and then I can have a different set of settings for B all the way through F. So I get 6 different sets of settings with this one. I have a Bowden tube on here, so I'm not going to need 6 millimeters. I know that. Let's do some 0.5s, and let's do 1 millimeter here. And then speeds, let's say that, let's see if we can go down to 30, 40, 50, 30, 40, 50. Now, I will say that there are much more challenging retraction tests than this one, where it's almost impossible to get the retraction tuned perfectly. This one's pretty good because it's sort of realistic. You're not trying to print these super thin little things. It does take longer to print, but this one, a lot of times, most all your settings will look decent, which is okay. And then you just are trying to find what's the slowest I can go. So what I've got is I've got 3 layers that are going to be the shorter retraction at 3 different speeds, and I've got 3 layers that are going to be a little bit more retraction at those same speeds. So I'm looking for which combination, and you can do whatever combinations you want. I'm going to leave all of these the same, as I'm trying to really focus on distance and speed. We will leave that alone. This is the base feed rate, so depending on your printer, you might be printing at all different speeds. Here's if I want to do some additional G code, and we'll just download the G code and we'll see. I don't know if it's going to print too well on this particular printer or not because of running Clipper, but we'll see. I need, oh no, it's 192, isn't it? There we go. Let's see if we've got our Clipper front end running. You can also, while it's loading, hopefully loading, is it doing anything? Trying to do something. All right, so probably, let's go back over here. Let me investigate. Oh. Huh. Interesting. Why is it not? Oh wait, alright, so there it goes. Just took it a while. So this is the clipper. I've shown it once before. This is the clipper front end. When we will talk about clipper, but it's a longer topic. One of the things here is that as long as you can get to a web address, then you can view, interact with your printer. So mine does not currently have a camera on it, so I can't view it, but I can see what's going on in there. So I am going to load up that file we just created. I assume it went to downloads. There it is. And we're going to try printing it. Again, we may have some issues that we have to deal with, but we'll see. Yeah, the other thing is it did not give me a, it just generated G code, so it didn't give me an actual estimated print time. But we'll just see what happens. Also, I could probably print a little faster, but that's okay. So it's heating up the bed right now, so we'll come back to it in a minute when it starts to do something. So the other thing you could do is Cura. You can just put a retraction test in here. There's the model that we had before. This little guy. Let's get him off of there. You can just add in a retraction test here. This one, the difference here, now this is a much shorter test, but here you will just get one set of settings. So you can go into your settings, look for retract, and you first of all enable it so that it's actually doing retraction, and then you can set up one set of options here versus the other one that we just did has 6 different sets of options. So this is a much faster print though, so it probably balances out in the end. Let's see where we're at on. It's almost got the bed heated. I think we'll come back to it. Oh, yeah, I was going to do this. You can probably hear the little bit of whine. Oh, there it goes, doing something. From the printer. Now you can actually hear the stepper motors. These are not the silent stepper motors. So there are the board that's in here. There are little computer chips called stepper drivers that are controlling the stepper motors, and they can be much quieter than this. So this one is definitely not set up for silent running. But while it's just sitting here not printing, you can still hear this power supply fan. It's kind of loud when everything else is quiet. So I was going to print. Now let me see what's going on. It stopped for a minute. Oh, it's got to heat up the nozzle. All right, so it's heating. It's to do it in a weird order. I was going to print this little cover. Maybe it'll be our last print for today. I don't think I can finish it during class. But this cover will bolt over this fan duct over here that's on the power supply and reroute it. It won't silence it. It's called a silencer, but it's not going to silence it, but it will quieten it down a little bit. So I'm going to print that so that we can bolt it over here and cover up this exhaust. Well, actually, yeah, it's exhaust for the power supply to kind of make it a little quieter. Here it is, what it will look like when it's done, except it'll be green because that's what I got loaded in the printer. Let's see where we're at over here. All right, so we're almost ready for printing. And we'll see. Again, I don't know how long it's going to take because it didn't estimate it. It probably is not going to do a purge line either. So I didn't see a purge line in the little G-code generator. So we might have to help it. So if you don't print with a purge line, yeah, it's just going to go straight into printing. Then sometimes I'll give it a little extra help there to push some filament out to make sure that it's going to actually start printing. That looks okay. I think it's printing the little base for it, so it'll stick down. Oh, it did print a skirt. All right, So we'll let it do its thing for a while. It says it is 3% done, so maybe it'll get somewhat finished by the end of the stream, but it won't be all the way finished. Let's talk about another piece here. So the other piece that I had was flow rate. So this one is called different things in different slicers. Some of them call it flow rate, some of it called extrusion multiplier, and we've used it already a little bit where we could, I think I may not have done it on the stream though. I was having the first layer just be a little bit thin on some of the prints, so I went into Cura and I, instead of looking at retract, I did flow, and the top flow rate, or the initial layer flow, that's the one I changed. It's not in here, but if you want that, if the first layer, maybe it's just not sticking, you've tried all the other things. One thing you can try is just for the first layer, increase that flow rate a little bit so it's spitting out more filament to really get down stuck to the bed. And so I did that, and it cleaned up the first layer a good bit. Your first layer is really dependent on getting that nozzle exactly the right distance from the bed. So if it's not quite close enough, one way you can make up for it is increasing the initial flow rate. I'm going to go back to 100. Now, this flow rate is, you know, kind of the overall print. Now, Teaching Tech does have a flow rate. Let's see which one he does. Slicer flow calibration. Now, he's got two here. So, the flow calibration from the slicer is the one we're talking about right now. But there is another one called, what's the maximum flow rate? And there's a couple of ways to do that. So, this one is going to basically just print an open box so that you can get in there and measure the wall thickness, assuming you have some calipers. So you do need some relatively accurate calipers. We're going to use, these. Maybe we should have done this test first because it's a much faster test. We could actually finish it in the stream. And we wouldn't have to listen to the printer. It's trying to do its thing over here. I think it's going okay. I don't know how many bottom layers it does though. So the way this one works is, again, you tell it what slicer do you plan to use. This one is giving you it doesn't generate a G code on its own. You use Cura to do this, or Simplified 3D or Prusa or whatever you're using. So first we need to download this cube. Now this cube is just I think it's 20 millimeter cube. So nothing special about this, but I'll go ahead and download it. There it is, Cube STL. Let's go to Cura. Close this guy. Get rid of this one. Let's open that cube. That's what it says to do. So that's probably in downloads. Oh, it's actually a bigger than 20. It's actually a decent size. Alright, so now it says turn off infill. Okay. I'm probably going to need to do this so you can see them. Alright, so we'll go in here, look for infill, and there it is. You can't turn it off necessarily, but you can set it to 0. So we'll do that. Now, one thing, when you're doing these settings in Cura at least, it will remember your settings for the next print. So remember all the things you did so that you can undo them. So we got 0% infill. No top layers, so we want it to be open because we want to get our calipers down in there. So top layers, we're on infill. Walls top bottom, so no top layers. Okay. Now ensure the wall thickness is a known value. Normally your wall thickness is the same as your nozzle diameter. So let's check on that. We've got, well, we should have a 0.4 millimeter nozzle. We'll keep those. So now we've got a 0.4, but we need our wall. So I think Cura, let's see, do they call it wall or line? Oh, there it is right there. Wall line width. Line width, 0.4 millimeters. And so if we print this thing with a 0.4 millimeter nozzle, the little printer is going crazy, with a 0.4 millimeter line width, then when we go to measure these walls with our calipers, they should be 0.4 millimeters. Set outer wall thickness to a single extrusion. Now, that's okay, and it will make it print faster. I would actually do two walls so that you can see how they interact with one another, but let's just do one. So wall line count will just be 1. Okay. Let's make sure the flow rate is on 100%. So I think it is. We just looked at it. Yes, it's on. The overall flow is on 100, and all the little special ones are at 100. Enable vase spiral mode. That's optional. So what this is, actually it says not recommended for Cura. So the spiral vase mode is, instead of printing a layer, moving up, printing a layer, moving up, printing a layer, it prints everything in a helix. So it only prints one outer wall and no infill. There are a lot of use cases that take advantage of that, but it says don't do that for this test in Cura. So this is what we're looking for when we slice it. So let's close this. Let's slice. That's 50 minutes. Whoa. That's a long time. But there's what we're getting here. Yeah. I don't know if you... Alright, let me show you what I just did. So in Cura, the color scheme, you can have, it's usually, that one just showed up as yellow, but you can have a different set of color schemes if you want to investigate certain things. Like, for instance, I've got the line type here highlighted, and what it's showing me is it's going to put the Z seam right here. This might be useful for your benchy. So the Z seam is usually visible. It's where the layer started and ended. And so if you can, this is not a great place to put the seam because it's going to be pretty visible. But while we're waiting on this to happen, let's look up Z-seam and Z-seam alignment. Let's do sharpest corner. Now it put it right on a corner, and that's going to be a lot harder to see because it's already a transition from one side to another. So that hides the Z. That's a way to hide the Z seam. There were other options in there too. Let's look at flow. So this one is showing how fast are you asking the printer to deliver filament, because there is a limit. Now this one, even the upper end is 1.6 cubic millimeters per second, and that's only like right here on the skirt. I don't see any other, well, the bottom, the first layer is red. So that's well under your printer's limit. Your printer, base regular printer, is probably good all the way up to maybe 10 cubic millimeters per second. Actually, I've got a little, this is from Crucial Research thread there. These people, they took Stefan from CNC Kitchen, they took his approach of just extruding filament, not trying to print anything, just extruding filament to measure it. So he had a scale where he could, like a very fine digital scale, where he could measure how much filament came out and measure how much he asked to come out, and then plot, you know, how much, well, let's see, here's one. Plot the amount of filament. Where is it at? I guess it was this one. Plot the amount of filament that is coming out at different temperatures, different speeds, all that kind of stuff. And this one also has some charts here that kind of show, you know, for PLA. Oh, I don't know what kind of printer they're using here. Oh, it's a Prusa MK or Mark III S. Different printing temperatures, so obviously higher temperatures the filament is softer and easier to flow. It looks like they start getting somewhere around, actually around 7. Looks like around 7 they start dropping off. Now the lower temperature drops off way faster than the higher temperatures. Higher temperatures have their own downside. They get a little bit more stringy, but maybe the 200, I normally print at 205, so between these two, looks like around 7%, 8%, I'm still getting over 90% of the flow that I'm asking for. Alright, I think we're back-ish. So, our little columns here don't have any stringing. Between them. So, all of these settings that we set in our over here. Well, not on that one, on the retraction, or seem to be working okay. So in that case, if these are all okay, I would go with the lowest ones. The least amount of retraction and the slowest retraction speed. And, well, I can see a little bit of their super fine wisps. I don't know that you'll be able to even see them unless I get it off of there. But they're about the same at all the levels, so I'm not too worried about them. Now, it could be, since I'm running a different operating system, it could be that the Clipper firmware is overriding the G-code retraction settings. That's possible, because this is really not set up to run with Clipper. So it could be that Clipper is just taking over and it's doing its own retraction settings. If you're using Clipper, you might have to do some different things, but this is a general process. He even has a little video of interpreting the results. In his video, you can kind of see, let's see if I can get it. You can kind of see, down here towards his lower setting, the lower settings, there's a lot of stringing on that first layer. And then there's some blobs on the second and third layer, but then as he gets higher, you can kind of see maybe this, whatever his 5th layer of settings were, or where it starts to clear up pretty good. You'll probably not be able to get rid of all of the stringiness, but you can minimize it and then clean it up with a file or with a heat gun or whatever you might need. Here's kind of another picture of reading some of the settings, how you can kind of see they get a little bit worse as it goes on. Although that's weird because those are the higher retraction distances, but that seems to be what it's showing there. Alright, so I think that probably gets us, well, I'm zooming the wrong way, probably gets us pretty close. It is almost done. It's on the last layer of print, so we'll be able to do our flow test. I don't know how many individual layers it has in this last block, but it's on the last set. Oh, there it goes. All right. So let's see. This is not stringing right here. That's from the skirt. Oh yeah. So these PEI beds, they are really nice for holding the print, and then once the bed cools down, they're really nice at releasing the print. So if you're having some adhesion problems with the first layer, the PEI sheets are really good. You want to clean it off a little bit. Another good bed is the, let me see if I can find it. I'm going to Amazon and I'll see if I can find it. I don't remember. Oh, here it is. These, if you can find one that fits your printer, they're different sizes for different printers. These Cryo Grip or the BQ, there's 2 of them. Can't think of the names of them now. There's this one, the Frostbite, Oh, there's all the different sizes. And then there's the other one, the Glacier. They're for different materials. So the Frostbite, which one is it? It's for the PLA and PETG, and the Pro Glacier is for more custom material, like not custom materials, but higher end materials like ABS and stuff like that. So the Frostbite, they're expensive-ish, $26. Well, you're probably going to need. Actually, I don't see one that's a Ender size. This one would be close. Maybe they don't make one for the Ender 3 size beds. I think they're a little bit bigger than 235. I don't have a. Yeah, here we go. Let's see. Let's see. Let's just measure. Oh no, that's exactly the 235 is the Ender. I thought it was 225 for some reason. How much is that going to be? $30. So they're a little bit expensive, but they are really good surfaces. They're a little bit textured. They give you this texture. So, well, I don't want to show that thing right now. Do I have anything that has... Oh, I printed this on it. All right. So they give you this texture right there. So it's similar to the normal textured PEI like this one, but that's what they give you for a texture. But they're really good grip. They hold on parts really well. All right, so let's look at our retraction test and see how it did. So you can see a little bit of stringing, you know, on this side. Remember, I had Z-Hop turned off. So turning Z-Hop on might actually fix a lot of that, because it looks like I can actually see it better on the camera than I can in person. See all these little bitty bits there, and on the other side? They don't seem to be particularly better. They do get better the higher I go. You know, they are a little bit worse at the bottom. So that bottom, those bottom three are the 0.5 millimeter retractions and the different speeds. And they do seem to be a little less noticeable on the 1 millimeter. They're still there though. So probably what I would do is I would turn Z-Hop on and see if that fixes those. That might be a better way, versus, because the settings are all about the same, and we're really zoomed in. You know, this is 1/2 inch. Each one of those squares is 1/2 inch, so we're really zoomed in pretty close. Probably my next bet, or my next tuning thing would be, let's see how Z-Hop works on this, and the higher settings. So maybe 1 millimeter. The speeds don't seem to make a lot of difference, so maybe the 1 millimeter, but 30 millimeters per second, and see how that goes. We're not going to do that right now. We have enough time, though, to do our flow test. Oh, although, remember, it said our flow test was going to take, said it was going to take 50 minutes. We don't have time for that. So, I do like that this one is larger, but that's taken too long for me. So, let's do the same thing, but let's scale this guy down. So, let's scale it down 50%, so that it's not going to take as long. How long is that going to take? 15 minutes. That's still a little bit long. Let's say that we don't need quite as much in the Z direction. There we go. 8 minutes. All right. Let's do that. Well, let's preview it. Make sure we're doing. Didn't change it. That looks okay. Save it. Dogs decided something's interesting. Let's save it. That's fine. Cube. Save. Let's go over to our Clipper G-code files. Upload. That's going to be on the desktop. There's a bunch of them. There's the cube. And let's print that. Alright. Oh, here's way zoomed in. Let's zoom out and see if we can have something happen in there. All right, so the idea with this one will be we will go in, print our little cube. Again, probably a bigger one would be more realistic, more useful, but we're going to print the smaller one just for time. And then we will measure with our calipers the actual wall thickness. We'll measure it 2 times on each wall. So we'll have 8 measurements. We'll average those. They need to be 0.4 millimeters, but if there's some other number, maybe it's over or under extruding, we can go back to Cura, and in our flow rate, we can up our flow if we're under extruding, you know, our walls aren't quite as thick as they need to be, or we can lower our flow if we think the walls are too thick. And so we can either just do, I usually just go up or down by 5%, but we could calculate the actual ratio of how far off we are if we wanted to try and be more exact. Typically 5% increments are going to be fine, but we'll just see. We'll see how it looks. So right now it's trying to heat up the nozzle. This one we did slice in Cura, so it's going to do a purge line and all that kind of stuff. And we'll see where it's at. Let's see, what can we look at while it's doing its thing? Any question? No new questions. I think, like I mentioned before, we're going to use Tinkercad. So it is called CAD, but again, it's more just a modeling thing. It's a very different approach for modeling geometry, and it's very accessible to anybody. But it has limitations, a lot of limitations compared to SolidWorks and Fusion and those kind of things. But I think I do still use it quite a bit because, for one, you don't download anything. It runs in your browser. It's free. You do have to have an Autodesk account, but those you don't have to have a paid account or anything. It's just you have to register. And it is generally pretty good. I think it'll make this part pretty easy. We do have to figure out, like I said earlier, how we're going to divide this into 2 printable things. What I'm thinking maybe is there's a little, I don't know, little circle right there. We may cut it there, and that way we can print them both standing up on their ends and then glue them together. Well, let's get that off of there. Alright, so it's doing its homing routine. Using the, again, this one does have the little Z probe. That is the CR touch, similar to the BL touch. Now it's going over, it's going to print a purge line. The purge line is another way to make sure that the filament's already flowing, so that you're not having to worry about, you know, the first couple of lines that you're printing not being there. Alright, so it's going to do the skirt, which is what I normally use for a purge line, but this one I have both of them on. And usually while these are printing, I'm monitoring it so that I can, you know, I'll even go and, you know, flick the thing to make sure it's, I can't get into that one, but make sure it's stuck down, because you have time to adjust the, you know, the corner knobs if you find a corner is too high or too low. Most of the time, you're printing just in the very center of the bed, so you don't have to be that accurate, you know. Very rarely, anyway, are you using the whole bed to print. If you are using the whole bed to print, that's when you need to start making sure your bed is as flat as possible. You might even want to switch to a glass bed so that it is flat, like a piece of glass, versus potentially bowed or whatever that the metal can be. So it does have to print some bottom layers. I think I had it set to 2. If you are so inclined, you get your first layer done, and your print seems like it's going pretty well, you can go into your screen here and change your feed rate or your entire printing rate. On this one, it's called feed rate. It is a percentage. So if you think everything's going well and it's not, the printer's not maxing out its flow rate or its speed or anything, you can go in and bump up the feed rate to 110% or 120% or more. If you think things are, it needs to slow down, you can do the opposite. You can go in here while it's printing and lower the feed rate to give it a chance to, save the print possibly. This one, in this menu here, I can change the speed, so how fast it's printing. I could even change the flow separate from the speed. So maybe it looks like it's over or under extruding. I can change the flow rate while it's printing to adjust for that. Since we're getting close on time, and it has printed, I probably wouldn't want to change any of these during a calibration print because you're trying to measure the baseline. So probably not a great idea to go changing them right now, but I do want it to hurry up and get done. So I'm going to change our speed to, I don't know, let's go to 120% just to speed, or 125. And you actually heard the motors change pitch because they're running faster now. On the nicer printers, it's a silent driver, which means you normally don't hear the stepper drivers or stepper motors. But it's going a little bit faster now, so I probably won't use this data. I'll print the full thing to do the calibration, but I'll show you how the calibration works. Let's see. So it says it's 65% done. I don't think there's quite enough yet for me to measure. It's still pretty thin or pretty short. All right, let's just call that. Where's the... Well, I might have to change it, shut it down over here. All right, so I canceled it over here. So you would have a little box, right? You would take your little box. So this one is very little just because we're trying to do it fast. Get your calipers out. Zero them so that you, all right, these are zeroed. And then you would measure maybe here. So actually this is showing 0.46 here, 0.46 again, 0.56 there, 5.1, 4.9, 4.3, 4.2, and 4.1. So one wall is actually pretty close. The other three are over extruding. So you would go in and average those 8 measurements, and then you would try to adjust the flow based on what percentage are they. Those seem like they were probably averaging 0.47-ish or so, and I was asking for 0.4. So I would have to find a calculator, which I don't see right now, figure out how much percent I'm over extruding, drop the flow rate in Cura, so go over to Cura and drop the flow rate by that percentage, so I don't know what it would be, 93%, and then reprint and do that process again. So try to hone in on getting the right amount of filament coming out of the nozzle. Now at some point, if these start getting too low, like in the 90 or less range, then you have to start thinking that there's another problem. So it may be your E-steps are not calibrated right. Your filament diameter is wrong. So, you know, your slicer's assuming that the diameter of your filament is 1.75 millimeters. Maybe it's not. You know, maybe it's, this one's exactly 1.75, at least in that spot. So, you know, maybe there's some other thing that's causing it to be so far off. You really don't want to drop outside of, for me, I wouldn't want to drop out of 95 to 105% range without trying to figure out, well, why is it so far off? Probably my E-steps are wrong. I've got the wrong size filament. You know, it's a bad roll and it just wasn't calibrated right. Something weird is going on. And again, our little test, we kind of invalidated. For one, it's tiny, but we also sped it up to get it printing faster. So do it the right way. Check your flow rate and see what you're at. So that'll get you your flow rate and your retraction dialed in pretty close. And those can be 2 of your calibration prints that you run. Also, speaking of the calibration prints on canvas, whatever you do for calibration, the point isn't necessarily to get it perfect for the course. You can keep iterating as many times as you want to. For the course, you just have to print one and comment on it. So you print your retraction tower like we did, and you say, oh, you know, it looks like the retraction settings are best here. My next step would be, and you don't have to go do the next step. You don't have to iterate over and over and over again to get it perfect for the course. You just have to do the calibration once and then comment on how you read the test print and then what you would do next. Maybe you do nothing. Maybe it's great. Or maybe you would change these settings and print again or whatever. So you don't have to iterate over and over again for the course. All right. We will be back Wednesday. I think we'll do some Tinkercad modeling for this thing. And I think there was something else I had set up. Let's see. Oh, yeah, some of the AI tools. I think we're going to look at some of the AI tools. I do have lightweight PLA down. I don't know if I'm gonna get some of this lightweight PLA that we can use. Oh, you can't see that. This, but it may not come in by Wednesday. So whenever that comes in, we'll look at lightweight PLA. This is even called for aero, like aerospace, although not aerospace, more like RC airplanes and rockets and stuff. All right, we'll be back Wednesday, 8 o'clock, and we'll